Welcome to week 5. We are almost done. Our agenda for today is going to be data management, network storage, and then the all nice determining storage needs. That's always a good one because we talk about storage in a way we need more storage, but storage is an expense. So we have to have an accurate way to determine storage needs. That way we're buying the appropriate amount of storage, not spending too much, not spending too little. So without further ado, let's get into data management. Our data management section, it focuses on managing of the data. What do I mean by that? Data management focuses on where will I store the data for my organization. Will it be on-site? Will it be off-site? Will it be at multiple locations? What type of media should I store it on? Are we talking about data that's going to be currently used? Is it going to be long-term storage data that's archived or backed up? All of those are important questions. What type of media? Is it going to be on a NAS, or is it going to be on a SAN, or is it going to use SAS drives or SSDs, or is it going to be traditional mechanical drives or SSDs? Those are all important underlying questions for the media aspect. Why does that matter? That's one of the biggest questions that I get asked the most frequently, or frequently asked questions. I deal with enterprise class NASs and enterprise class SANs. They may be hosting a server farm's virtualization, and so a traditional SATA hard drive just doesn't have the long-term durability, reliability, speed that our larger server farms need. It could be SAS, it could be SSDs, it could be a hybrid type drive of enterprise class SATA drives that also have some hybrid drives where they're half SSD, half mechanical. It kind of just depends on what we're storing, what's its data worth, how quickly do you need data access from it. Those are all very important questions. Lastly, how do I maintain it, keep it safe, retrievable if there's a disaster, and how do I make sure it's available even in the case of a disaster? Availability, retrievability. How can I gain access to my data if something happens? Those are important questions. 9/11, while it was a tragedy, loss of life, the towers actually also had large data centers. And when those data centers collapsed, they also took with them small businesses and medium businesses' data. The companies were not located there in the World Trade Center. Just their data was. But overnight, those companies were gone. They put their data in the cloud, and they assumed it would be safe, and in reality it was not. And long-term consequences, most of those businesses are now shut down. So, let's go ahead and get into just our data management lifecycle. There is normally two things. The data is created. Part of that creation could also be organization, turning that data into information. Then data is saved for being able to be retrieved a little bit later. So now let's look at specifically data is created. What do I mean by data is created? It's usually done by the end user via some type of application or a system. Could be a system routine that's configured within the application that draws from existing data to create new data. So this was true with the Internet of People. Now we're transitioning to the Internet of Things and to the Internet of Everything. And what I mean by that is it's no longer tied to an end user. It could be a device, could be a refrigerator, could be a microwave. It could be any smart device that is using existing data and then generating new data. A smart refrigerator is a great example. It takes existing data. How much does a gallon of milk weigh? You program the refrigerator so that that's where the milk goes. You put the milk there, and when the milk gets to a certain percentage or to a certain weight, it lets you know you're almost out of milk. That is one of the ways that data could be created using a smart refrigerator. The system routine could also pull data out of a database. This normally would be done with the help of a person, but again, with the Internet of Things and Internet of Everything, these could be just other devices. Thing here is we're taking already existing data and we're generating more data off of existing data. And it's not a human being able to interact with it, it's just new items. Next, data is saved. Again, this is normally done by an end user, but it doesn't have to be. With our current day algorithms and our current day smart devices, we can program it to auto-save. We can program it to save. You're no longer tied to a human having to save things. That's been a huge thing because we're kind of flawed. At this point, this is where our storage management cycle truly begins. So, what storage media should be used to save data? Kind of just depends. It used to be magnetic storage. Could be a hard drive, could be a tape, could be the same server or workstation where the data is created. The point here is it doesn't really matter the media per se. It's more about on-site, off-site, how available will it be? What's the availability of the data like? If there's an event, are we going to have access to that data? Is it backed up regularly? How current are the backups? Those are important questions. The actual, what media, those are important, don't get me wrong, but first thing we have to figure out is some availability questions, because depending on availability demands, that could then change your outlook on storage. For example, you want really quick read and write access times, and you could be thinking, well, initially I was thinking mechanical hard drive. Well, if the requirement then becomes a very specific, the speed of read-write access, you could then say, oh, well, I need SSDs. And you can use that as justifications, or justification. So it kind of just depends. If you were to store data in some other type of media, keep it long-term, could keep it from a different location. What about not so much having data both on-site and off-site, but being able to pull from data off-site? It could be that if you tried pulling data from an off-site location, you could experience delay in performance because you're having to read the data through the internet, through your network, through the wherever you're pulling the data from, their network, and it just becomes overly cumbersome. But a benefit is it's not at your location, so if a disaster hits your area, you won't have to worry. So I mean, it just kind of depends. At what point can you go, okay, the performance related issues of data that's stored off-site is worth the delay. It just kind of depends on your circumstances. Don't get me wrong, we only talked about a few ways data is saved. There are way many more technologies out there that are trying to answer the important question of how do I save my data? How do I grow my data within my existing infrastructure? That's a huge question that's not going away. Next, let's move on to network storage. So we've talked about network storage back in week 2, but there's a few things that I wanted to make sure to cover again, just to make sure. Things like our direct access storage. Is that going to be network-based storage, or is it going to be storage directly attached or connected to the individual computer or server? Because there is a difference. If it's not directly attached, either via like USB, FireWire, SATA or eSATA, or some type of additional type of proprietary connection, because I know there's specialized SAS cables as well, it's going to probably be network-based storage. But how does that differ? And that's an important question, because people don't always see the difference between SAS that's directly connected versus SAS that is network. So let's talk about what exactly does it mean by direct access versus SAN-based. So DAS versus SAN. So here's a great example of a MD3000i SAN. Let me zoom in a little bit. So this unit has network-based iSCSI capability. So that's going to be a dedicated network for storage, a dedicated network for management, and then it also has an additional SAS port so that we could daisy chain additional storage units off of this. This is going to be a SAN controller. Here's a little closer photo of that SAN controller. It has a power supply, it has the management, has the 2 iSCSI connectors, and then it has just the SAS out. So what is this SAS out? This SAS out allows you to directly connect other storage units to this. So you could have a DAS unit connected to this, and this would be our storage area network. So here's a great example of a DAS unit. It has a serial in, has a serial out, has some additional serials for additional items, but that's what I want to focus on. This unit would peer with the unit above it so that you can scale out a SAN unit. So what exactly do I mean by that? Here we go. This is our network-based SAN. These would be add-ons to that SAN that are directly connected to that SAN. So that DAS unit, direct access storage, would be these bottom two. They are directly connected to our SAN. Now, if you had that SAS port, because you can buy that as a serial port, or a PCI Express port, sorry, you can have these directly connected to a dedicated server or workstation. It just kind of depends. But if you don't have them dedicated or actually directly connected to an actual server, you can have them directly connected to another SAN and then have that SAN manage it. And actually, when I showed you the photo earlier, haven't showed it to you quite yet, it's going to be this type of setup right here. It's going to be a combination of multiple SANs stacked with direct attached storage, because this guy up here is fairly expensive, and then the direct attached storage units, because there is no the controller, the unit that controls the storage is not network based, so it's a lot cheaper. So it's actually easier to scale out our storage networks like this than it is to have a bunch of SAN units, if that kind of makes sense. So I did want to share that with you. One of the last major things for this section is that our SANs do provide additional functionality. Sometimes those units, they have very specific items that they do, and that's kind of a big plus. That's why we go with them, because they are that great. That's really it for the SAN section. Week 2, we cover this way more in depth, so I did want to share that with you guys. Thank you. Determining storage needs. So one of the big questions is, why do we need to determine storage needs? As I said earlier, storage is a resource that does cost a great amount of funds. So making sure that we have the appropriate size storage is pretty important. Whether it be a small office, a home office, a big office, a medium business, it really all depends on how much data they're consuming and then generating, and what is that data worth. Because depending on the different type of storage technology, you may be able to push off bulk of the data to slower drives if it's not business critical to have it readily accessible. What I mean by that is, if we generate thousands of contracts each month, but they only get reviewed once every few years, we could put them on slower storage without a problem, because it doesn't need to be on fast access storage, because they don't get read all that often. When it comes time for them to be read, we can pre-do some of that work and go ahead and move them to faster storage only as required. So, when selecting the data storage methodology, the system admin needs to determine how much space. We need to be able to calculate the appropriate space, as well as leaving room for growth. The reason that this is important is, again, because storage is a resource, and it can get extremely expensive. In my organization, I take care of all of our storage. We had to purchase 3 SANs, and to populate them with drives, the drives cost more than the storage unit itself. We actually were looking at long-term storage for readily available video. We take care of a gun range here in town, and they wanted to be able to on-site record 30 days worth of content, have it readily available on location and off location, and we came out with an Axis camera system. Axis came out and helped us pick out all the parts, and then the network video recorder that they picked out, it was essentially a 45 terabyte storage unit per location. We could have one inside the office, and we could have one at our data center, and they would synchronize between one another. Or you can set it so that one is the master, one is the slave. Just kind of depending on how you want to get it set up, it just kind of depends. But for just that storage, we're looking at dang near $30,000 for all the large capacity drives and the enclosure. The enclosure, again, was the cheap part. The drives are what cost so much. But for that business, that was totally acceptable, and they went ahead and they bought it. Bought both of them. One on location, one off-site, because that was something that they absolutely needed. For most businesses, that's way too expensive. But again, data is what drives our business. So being able to store and analyze that data, that's a huge thing. So again, normally in the smaller businesses, we're looking at the gigabytes of data. The larger the organization, we start going into the terabytes of data. 40 plus terabytes of storage just to record video for security cameras. But at the same time, because it's a gun range, the second the store got broken into, all the cameras were higher quality cameras, so you would be able to make out people's faces. You would be able to capture fine detail. There wasn't no fuzziness to any of these cameras. Most of the cameras were 1080p, and so they did record in a higher definition. Some of the cameras are also recorded with night vision, which just jacked up the size. But again, if they were able to prevent 1 or 2 thefts each year, the unit paid for itself hands down. So again, items to consider. What about local storage versus external storage? Does it have to be internal to the computer that you're using? Can it be network-based storage? If it can be network-based storage, can it be storage off-site? Could it be storage on-site, being backed up to a cloud nightly? Again, it just kind of depends. What about data storage size and transfer between the devices? How quickly does that data need to be accessible? If we're talking it's everyday data that's being used regularly, it needs to be readily available. The slow transfer speeds between devices wouldn't be okay. But if it's long-term stored data, the slower speed may be okay because it's not being accessed frequently, so they know you put it on slower storage. Again, just depending on how you want to do it. For my business, what we end up doing, we have all 3 SANs, 2 of the SANs populated with a combination of SSDs and SAS drives, because that actually houses our virtualization, that houses our data storage, that houses our just data. For our backups, we use a third total SAN, and that SAN is populated with SATA drives. The SAS drives are pretty expensive when we start getting into the terabyte style drives. So what we end up doing is, for our backups, we use SATA enterprise class drives, so they're not as quickly accessible as the SAS drives, but terabyte size drives by far cheaper, so we're able to recoup some of the costs there, because we can pick up a 2 or 3 terabyte SATA drive for about $150, $180. If we wanted to do that for a dedicated SAS drive, we're looking at $400 or $500 per drive. So price does matter. So once you calculate cost and everything, is the data going to be safe? So we have to talk about disaster recovery. Is it on-site? Is it off-site? Does that matter? And it does matter. Being able to store your data in such a fashion, so if one location is taken down, you have another location, that's important. And sometimes it's not the primary location that gets hit. Sometimes it's the backup location. So that's another item to consider. Let's look at costs per device. So we have to look at the dollar value. So how do we do that? Normally, if we're doing it for a network, we can take how many ports, divide it by the price, and we get price per port. But with storage, we're going to do that price per megabyte, gigabyte, or terabyte, depending on the storage. So let's assume we have 15 drives in a SAN. Each drive is offering about 300 gigabytes of storage. So that comes out to about 4,500 gigabytes. That's assuming no RAID, no overhead, no nothing. Because realistically that'd probably be about 3 terabytes, but let's not go quite that far. So we take our total usable space, and we will take that total usable space and you divide that by the price of the unit and drives. So here we have about, again, 4,500 gigabytes of data. The unit itself costs about $12,000, so 45,000 divided by 12,000, roughly about $2.66 per gig. But let's be a little bit more realistic. Boop, let's open up our calculator. Let's assume some type of RAID 5, RAID 6. So let's say we actually have 3,000. That's how much data storage we're actually going to get. A third of it's going to be set aside for parity and backup. Not backup as like backing up the data, but parity backup for the drive on the SAN. Let's divide that by 12,000. And we start getting different prices. So, you have to be kind of careful when you do the calculations. The 4,500 gigabytes of data, that's going to be, assuming all of the data is going to be readily available. And on a SAN, that's not going to be the case. You're going to pick a RAID type, and then from there, you're going to lose X amount of space. So let's look at a realistic view. I actually have logged into my Dell Disk Storage Manager. This is actually running 3 of my SANs. So here we actually have our 3 SANs. We have 3 enclosures populating around about 32 disks of storage. And total we get about 13 terabytes of data. But when you start calculating it out, we have way more data than that. But because we have a combination of RAID 5 and RAID 6, depending, what ends up happening is the RAID 5 and RAID 6 have the parity. So even though we have, let's say example here, our web VM, I dedicated roughly 750-ish gigs to them. I'm going to round up. So 0.75 terabytes of storage to our web VM. But realistically, the drive space that that's running on is actually a terabyte. Because a little over a quarter of it is just the parity for the backup. That way, if a drive dies, there is backup. Because that's the thing. With RAID 5 and RAID 6, yeah, we do them so that if a drive does die, because it's going to happen, we have a replacement. I have 32 disks. The likelihood of one of them dying, it gets up there. But I do it in such a way, that way my primary items are in RAID 6. That way, if there's a failure, I can have so many disks fell before I have to start worrying. Normally, with this type of setup, 1 disk, no problem. But it's always good to know. We're going to ignore the fact that this array is non-optimal. I have a RAID battery dying, so it just turned non-optimal today. But I wanted to kind of point this out because we talk about it, but how do we know if it actually works or not? So I did want to point that out. Sadly, I cannot show you my breakdown for my capacity. It won't let me. But I can click on physical disks to show you kind of our manager. I have 400 gig disks. About roughly 370 gigs per disk is available. And then you can tell which ones are in RAID 6. They're going to be a hot spare standby. If they're assigned, what's their health? That's the end of one unit, because each unit handles about 15 drives. The second unit, we didn't really need a whole lot more data, so we just populated it with 150-ish gig drives. Notice I have 2 that are unused, and I have a free space. So I could populate more storage if need be. On the third storage array, I have 3 2 terabyte SATA drives, but notice it'll even let you know. This is a whole brand new enclosure. just in case you didn't see it enclosure, this is all the second enclosure, but I did it on a whole separate unit. That way, if there's a problem, I wouldn't have to worry about my primary storage being data having any problems with other SATA drives or anything like that, because that is a concern. If you're using SAS and SATA, can they intermix? And this unit, it said yes, but I didn't want any performance issues, so I didn't want to take a chance. So I just, nope, brand new unit, put SATA in it. That way I can populate this with just SATA, and I'm guaranteed it will be okay. Okay, so that's it for today. I wanted to thank you guys. Oh, you know what? I take that back. One more slide. You're going to use this type of methodology, the cost methodology, to help support your vendor purchase. Why are you getting that 300 gigabyte drive? Can you get it cheaper? What about interface type? Could it be SAS, SATA, SSD? Doesn't matter. What about how quickly the disk spins? All of those are great questions that you're going to have to justify why you're using. Normally, I do a mock write-up. SAS is faster, better availability, things of that nature. And I've never really had a big issue getting people to sign off on the storage, because companies realize they need storage. They also realize that they need storage that's going to be readily available and is going to be there in time of need. Better equipped storage. That's what I'm talking about. Okay, so that's it for this week. I hope you guys have a great week, and I will see you guys later. Thank you. Okay, so I wanted to discuss some follow-up items. One of the first things is our APA formatting and citation. That goes for both our IPs and our discussions. Remember that we have to do all of our work according to the APA manual. So if you're not sure how to do that, go online. You can type in APA formatting. If you don't want to look it up online, you can go to any of the tutorial services. We have a writing, we have a library service. They can give you additional resources on how to do APA formatting. That's important. That's not going away. In discussions, same thing. We have to be doing our citations in our discussions, because one of the big things is, for our citations, we're building off of other people's works. So it's a way for us to verify what we're claiming is supported by the literature. So when I say something at the sky is blue, you can take my word for it, or if I provide a citation, you can take an expert's word for it, and then I build off of that. So it just kind of increases your credibility. We should be at least citing in every post, or as much as possible, because again, we're trying to link what we've done back to the literature. Same thing in our IPs. Every paragraph should be tied to a source. Every paragraph is an idea, and every idea we need to have support within the literature. And I know at this level it's not that big of an issue, but you want to get in the habit of doing that, so when you start doing higher level work, it's second nature. Also, length. We don't need posts that are great job. I mean, don't get me wrong, it does add to it, but when I start grading for posts, I'm not doing full credit for those that have 3 posts and 2 of them are great jobs. I don't count the great jobs as a post. For our discussion board, I'm looking for 3 solid responses with citations. For our papers, I'm looking for 3 pages of content with citations. So what I mean by content is, that's 3 papers on topic. That's not a cover page, that's not your reference page, that's 3 content pages. 2 if you're really good, but I'm really looking for 3. If you're doing diagrams, diagrams totally are okay, as long as you're doing them within APA formatting. Lastly, grading. Again, I grade heavily off of attempt, like if you're putting an effort into it. Like if you did 2 pages and you did a few citations, and I could see that you were making an effort, I'll meet you. But if you post once, or you did a page and a half with 1 citation, that really isn't you making an effort. If you get stuck, don't get me wrong, some people a page is a lot. If you get stuck, you have plenty of resources to bolster up your paper. You can contact me, I'll help you. If you don't want to contact me, we have a writing center, we have a tutorial center, we have plenty of help for you to get. If you need tutoring, there's a lot of tutoring out there. And again, provided from the school. All you have to do is say something. For our tutorial lab, we have tutorial services for SQL, we have tutorial services for database, we have tutorial services for math, English, writing, research, library services. I mean, we have a great amount of tutorial services. And if we don't offer tutoring in a specific area, you can ask for it specifically, and they will find tutors for you. So you could not get tutoring because you can. If you ask for help, the school will get it. If you cannot get it from the school, there's other help. I will sit down with you. I will do as much as I can with you if you need one-on-one. If you need tutoring and you don't get tutoring, that's not a failure on my part. That's not a failure on the school's part. That's only a failure on your part, because there's plenty of opportunities there. You have my number, you have my email, you have 2 emails from me, you have my cell phone number, you have plenty of ways to get a hold of me if you need help. And again, if you don't capitalize on help and you need help, that's on you. Okay, there's plenty of help out there. All you have to do is say something. Thank you.